This is a challenging wave question from RI. Now, this oscillator moves to the right, and also the wave also moving to the right. So this velocity of the wave, and v is velocity of the oscillator. I say the velocity of the source. Okay, this velocity of the source also means velocity of the oscillator. This velocity of the wave, I call it just v. All right. So since both are moving, there will be relative velocity between them. Remember, when you're in the same direction, you need to minus. So the relative velocity is v minus vs. All right. If you're in the opposite direction, you need to plus. Okay. Now let's take a look. How do we form this wave? Okay. You see, for this wave, it must be formed when the source is here, right? So when the oscillator is here, this is the wave. How to form this wave? The oscillator must be at the center of the wave. Where's the center? Center must be here, right? Then you will form this wave. Okay, let's learn where is the source first. Now, what about the largest one? The largest one you must form at here, right? So you will get the largest circular wave front. All these are the wave front, all right? Now, so what is this actually happening here? Now, this is now. This is earlier on. This is earlier on. This is earlier on. Now it's here. Earlier on, they produce this wave. Earlier on, they produce this wave. Earlier on, they produce this wave. So what is the meaning of earlier on? Look at the time travel here. 1 cm. The question says 20 cm in 1 second. So 1 cm, how many seconds? 0.05 second, right? So you know what is the speed of the source? Speed of the source is distance divided by time of the source. So what is this is the source that's moving from here to here to here to here. So in other words, when the source is moving to the right, you will see that the wavefront produced here is getting closer and closer. Just like imagine the source is chasing after the wavefront. That's why you can see them as closer and closer. Actually, this is an example of Doppler's effect, but this is not in your syllabus, the Doppler effect. I just tell you whatever you need to know. Now, distance is what? Distance is 1 cm, so it's 1 cm, all right? What is the time? Time is 0.05 second, so it will be 10 centimeter per second. All right, this is the speed of the source. Now, what about the frequency? You know, v equals to f lambda. They want you to find frequency, but this one, you must use relative speed. Relative speed in this case must be the v minus the v of the source, because they are traveling in the same direction for both of them. V of the wave is 20. V of the source we found is 10. Frequency you don't know, and the lambda. What is the lambda in this case? For this case, we need to use this as the lambda. We need to use this part as the lambda. Let me use another color. This part is the lambda, which is just 1 cm. 1 cm, 0.0. Okay, we stick to 1 cm because this is in cm per second, right? So it's just 1 cm. Okay. So finally, we get f is 10 hertz. That's what answer is B. Now, if you want to check this side, also can. If you use this side, then you need to use this part. Then you use this part. So this is 3 cm, right? For this left part, we need to use V equal to F lambda. But the V is in the opposite direction, you must use plus. V plus Vs. So F lambda. V is 20 plus 10. F you don't know, but this one is 3 cm. You will still get back F of the source as 10 hertz. You will still get the same thing. Okay, but what I want you to understand is when somebody stand here, you will see a lower frequency of you will feel lower frequency of a sound wave or the signal going to this person. When there's somebody here standing here, you will feel that very high frequency of sound because you see the wave seems closer. In other words, it takes a shorter time to receive each wavefront. You see, this is a shorter time to receive each wavefront. This one is a longer time to receive each wavefront. That's why you perceive a higher frequency signal here, sorry, you perceive a lower signal frequency here, and you perceive a higher frequency signal here. But this question, they never ask you so detailed, right? So they just ask you the speed of the oscillator. You just need to use the idea of relative speed. Finally, I would like to tell you that for this question, it is actually what we call Doppler's effect, and it's in H3 syllabus. It's not in H2.